Whenever a new space telescope goes online, we tend to project a very specific, almost romantic expectation onto it, I think.
Oh, absolutely. I mean, we spend decades building this incredible piece of machinery.
Right, and we launch it a million miles into the dark.
Yeah, and we just expect it to send back these majestic, serene baby pictures of the early cosmos.
We really do. We want to see the dawn of time.
Exactly. The narrative is usually about observing the universe, slowly waking up.
Like hydrogen clouds gently coalescing into the very first delicate stars.
Right.
And the James Webb Space Telescope, JWST, was explicitly built for this exact mission.
It really was. Its infrared cameras were designed to pierce through cosmic dust and look incredibly far back in time.
Because, light takes time to travel, right? So looking deep into space literally means looking deep into the past.
Yeah, precisely. So we expected JWST to show us this quiet, newborn cosmos that was just figuring out how to shine.
But instead, it stared into the ancient void and found something so disruptive. It has the entire astrophysics community rethinking their life's work.
It really is the definition of a generational scientific puzzle.
Yeah.
What JWST found doesn't just, tweak our models. It fundamentally challenges our baseline understanding of how the universe even operates.
Okay, so let's unpack this. Because the source material we are diving into today from Ziko's space stories details a discovery that is so wild, it might actually force a complete rewrite of the astronomy textbooks most of us grew up with.
It's completely paradigm shifting.
It is. We are talking about a colossal monster black hole sitting in the deep cosmos that, according to the current laws of physics, simply should not exist.
At all. It shouldn't be there.
So if you're listening to this and you thought you had a pretty solid grasp on the standard model of the universe, get ready. We are about to pull the rug right out from under you.
Yeah. To really appreciate the thrill of this mystery, we have to look at the standard rulebook for how black holes are, supposed to grow. Because there is a deeply established timeline to the cosmos. And black holes are supposed to follow a very specific evolutionary path.
They don't just pop into existence at the size of a solar system.
No, far from it. Under the standard model, a black hole only starts its life after the catastrophic collapse of a massive star.
Right, so a star burns through its fuel, gravity crushes its core.
It goes supernova, yeah.
And what is left behind is a stellar mass black hole.
Exactly. Which is maybe a few times the mass of our sun.
Okay.
But from that starting point, it takes a staggeringly long time. We are talking billions and billions of years for that black hole to swallow enough surrounding gas and dust.
And other stars, right?
Right, to eventually become a supermassive giant. It is a very slow, incremental process of cosmic eating.
Wait, I have to push back here for a second.
Sure.
Why couldn't this just be, a case of a cosmic feeding frenzy?
What do you mean?
Like, what if this particular black hole just happened to be born in an incredibly dense neighborhood? Like a packed cluster of ancient stars, and it just swallowed 1,000 of them at once. Why does it have to break physics to eat fast?
That's a great question, but there is actually a hard physical bottleneck to how fast a black hole can feed.
Really?
Yeah, it's called the Eddington limit.
Oh, okay, the Eddington limit.
Think of it like trying to shovel coal into a blazing furnace.
Right.
If the fire gets too hot, the outward blast of heat and pressure physically blows the next shovel of coal away before it can even enter the furnace.
Oh, wow. So the act of eating literally prevents it from eating more.
Exactly. Gravity pulls matter in, but as that matter spirals toward the event horizon, the immense friction superheats it.
Which creates a ton of energy, I imagine.
Right. It creates so much light and radiation that this outward pressure literally pushes the surrounding matter away.
So the black hole basically chokes on its own meal?
Yeah, it chokes. So because of the Eddington limit, there's a hard mathematical speed limit to cosmic eating.
Yeah.
You cannot speed run becoming a cosmic titan.
Which brings us to the core of the problem, because JWST didn't find this black hole in our modern 13.8 billion-year-old universe.
No, it didn't.
It looked back to the very dawn of time, capturing light from just a few 100 million years after the Big Bang.
Which is nothing.
Right. In astronomical terms, a few 100 million years is barely a blink of an eye.
The universe is practically still in its crib at that point.
And sitting right there, in that newborn universe, JWST detects a monster black hole that is already billions of times heavier than our sun.
It's mind-boggling.
It is.
Yeah.
Finding this black hole at this point in the timeline, I mean, it is literally like walking into a hospital maternity ward, a place meant entirely for newborn swaddled babies,
Right.
and finding a fully grown 6-foot-tall adult human being just casually walking around in there.
That is a brilliant image, honestly. And what's fascinating here is that it perfectly encapsulates the math.
Yeah.
You look at this adult in the maternity ward, and your first thought as a physicist is, how did you get here?
Yes.
You physically do not have the time to have grown this large.
I mean, you would think your instruments were malfunctioning.
Many people did.
Right.
Hmm.
Because if the universe is only a few 100 million years old at the moment, JWST is observing this anomaly.
Yeah.
And the Eddington limit strictly dictates how fast a black hole can grow. The math just completely stops adding up.
It really forces us into a corner.
How so?
Well, if you run the models of how fast a black hole can feed at its absolute maximum speed limit, there simply hasn't been enough time since the Big Bang for it to reach billions of solar masses.
Wow.
The timeline is mathematically broken.
So if the physics of how a black hole eats are ironclad, I mean, if the Eddington limit is a hard physical law we can't mess with,
Right.
then the only other variable we can mess with is time itself. Are we absolutely sure the clock started 13.8 billion years ago? Because according to the material from Ziko's space stories, that is the first wildly disruptive solution cosmologists are actually considering.
It is. That is the first option on the table, and it is a massive one.
The huge one.
We have accepted for a very long time that the universe is roughly 13.8 billion years old.
Right.
That number is the bedrock of modern cosmology.
Yeah, we learned that in high school.
But if this fully grown black hole exists when the universe is supposedly just a few 100 million years old, one logical solution is that the universe is actually much, much older than 13.8 billion years.
Meaning that maternity ward isn't actually a maternity ward at all.
Right.
We just misread the clock on the wall.
Exactly.
But, I mean, how sure are we of that clock? Where does the 13.8 billion number even come from in the first place?
Well, it comes from two highly reliable independent rulers.
Okay.
First, we have the expansion rate of the universe, which is known as the Hubble constant.
Right. The Hubble constant.
We can see galaxies moving away from us. And if you run that tape backward, calculating how fast everything is expanding, everything converges at a single point, roughly 13.8 billion years ago.
Okay, so we're basically cracking the physical movement of galaxies backward, like hitting a cosmic rewind button.
Yes, exactly.
Yeah.
And the second ruler is even more precise.
What is it?
The cosmic microwave background, or CMB.
Oh, the afterglow thing.
Right, it's the literal afterglow of the Big Bang.
Yeah.
It's this faint wash of microwave radiation that permeates all of space.
Okay.
And by studying the tiny temperature fluctuations in this afterglow, we can measure the precise age of the cosmos.
Wow.
So both the Hubble expansion and the CMB point to that exact 13.8 billion year timestamp.
So wait, to fix the black hole timeline by saying the universe is older, we'd have to toss out decades of Nobel Prize-winning measurements of the cosmic microwave background.
We would literally have to admit that we have fundamentally misinterpreted the afterglow of creation.
That is insane.
It is. If the universe is vastly older, say 26 billion years old, then this black hole would have had the time it needed to swallow matter and grow.
Right.
But accepting that means throwing out the foundation of observational cosmology.
Yeah, that's not just a minor adjustment.
No, it's a total rewrite of astronomical history.
Which feels like a monumental pill to swallow. I mean, you don't just throw out the CMB because of one anomaly.
You really don't.
But then we have the second option, which honestly feels even wilder to me.
Oh, it is.
Because what if the timeline is perfectly right, but our understanding of the black holes themselves is wrong?
Right.
Here's where it gets really interesting. What if black holes don't just form from dying stars?
And this brings us to the theory of primordial black holes.
Primordial black holes.
Yeah. Some very forward-thinking physicists are looking at this JWST data and suggesting a completely different origin story.
Okay, what is it?
They are suggesting that these monster black holes didn't grow over time. They were just born big.
Just instant cosmic titans.
Exactly.
But how? I mean, if they aren't coming from a collapsed star, what is creating them?
To understand this, we have to look away from standard stellar evolution and look directly at the Big Bang itself.
Okay.
In the first fractions of a second after the Big Bang, the universe wasn't just a cloud of gas.
Right, it was super intense.
It was unimaginably dense, hot, and chaotic. It was basically a boiling quantum soup.
So dense that the normal rules of matter haven't even formed yet.
Exactly. The idea is that in this extreme environment, Microscopic quantum fluctuations,
Like tiny variation.
right, tiny pockets of matter that were just slightly denser than their surroundings, could have been instantly crushed into supermassive black holes by the sheer crushing pressure of the early universe.
Oh, wow. So instead of like water slowly cooling down over hours to freeze into ice,
Right.
which is like a star slowly living and dying to become a black hole,
Yeah.
this is more like a chunk of coal being instantly crushed into a diamond by unimaginable pressure.
That is a phenomenal analogy, yet
That's crazy.
they bypass the entire life cycle of a star. They formed instantaneously in the quantum fires of the Big Bang.
But wait, if they were born big right at the dawn of time, doesn't that completely flip the script on how galaxies form?
It does.
Because we've always been taught that a giant cloud of gas clumps together, a galaxy forms, stars ignite, stars die, and then eventually a black hole forms in the center of that galaxy.
Right.
But this implies the exact opposite.
It reverses the causal arrow entirely.
Wow.
If supermassive black holes are primordial, if they were born big during the Big Bang, then they didn't form inside galaxies.
They were just already there.
Yes, they were already sitting there, acting as the gravitational anchors that drag the primordial gas and dust inward.
They were like the secret seeds of the universe.
Precisely. They forced galaxies to form around them.
That's amazing.
Instead of the black hole being a graveyard for dead stars at the center of a galaxy, it becomes the engine of creation that allowed the galaxy to condense out of the cosmic dark ages in the first place.
Which is an incredibly beautiful way to look at it, honestly.
It really is.
But as fascinating as that origin story is, this deep dive wouldn't be a scientific crisis if it was just a matter of, rearranging the chicken and the egg of galaxy formation.
No, the problem goes much deeper than that.
Right.
Uh.
Because this JWST discovery poses an immediate threat to the foundational rules of modern physics itself.
Yeah, if we connect this to the bigger picture, we have to look at the mathematical scaffolding this entire conversation rests upon.
We have to talk about Albert Einstein.
Yes, we do.
We are talking about the general theory of relativity.
Exactly.
Because this is the framework that has successfully explained the macroscopic universe for over a century.
It's everything.
It's how we understand gravity. It's how we understand the warping of space and time. But this new cosmic titan directly challenges our fundamental understanding of how gravity operates on a cosmic scale.
General relativity isn't just a neat theory,
Mm-hmm.
It dictates the growth of structure in the universe.
Right.
Our standard cosmological model, which is heavily reliant on dark matter and Einstein's gravity, predicts how fast matter is allowed to clump together.
Because gravity is actually a very weak force, right? Compared to like electromagnetism or the radiation pressure of the early universe.
Extremely weak.
Yeah.
In the early universe, radiation and heat are actively pushing things apart. Everything is expanding.
Okay.
So for gravity to win that tug of war and pull enough matter together to form a billion solar mass black hole in just 400 million years,
It's just not possible.
our current models of dark matter and gravity simply don't allow mass to clump that fast. The math that Einstein gave us to explain gravity's role in the cosmos does not predict this level of rapid structure formation.
Oh, man. You really have to put yourself in the shoes of a cosmologist right now.
Oh, I can only imagine.
You have dedicated perhaps 40 years of your life to balancing the elegant equations of general relativity.
Yeah?
You've built your entire career on the standard model of dark matter. And then a telescope powers on, takes a few infrared pictures of the dark void, and basically hands you a photo that says your math is a fairy tale.
It's a thrilling, yet deeply unsettling moment for the scientific establishment.
I bet.
We are standing on the edge of a new revolution in physics.
Yeah.
Because when the universe outright refuses to follow our rules, we don't get to fire the universe. We have to throw out the rules.
But are we genuinely prepared to accept that our fundamental rules of gravity might just be wrong? Or at least incomplete?
Well, if James Webb keeps pointing into the dark and finding more of these ancient monsters.
Which it might.
Right. If this isn't just one bizarre outlier, but a common feature of the early universe, then yes.
Wow.
The cosmological models we rely on will have to be heavily modified or they will completely collapse.
That's terrifying and exciting.
It means we are looking into a universe that is operating on mechanics we haven't even conceived of yet.
Like what?
Maybe gravity behaved differently in the early universe. Or maybe dark matter interacts in ways we haven't modeled.
It really humbles you, doesn't it?
It really does.
We build these incredible billion-dollar machines. We write these elegant equations on chalkboards. We think we have the universe mostly figured out and neatly boxed up.
Yeah.
but the universe is under absolutely no obligation to make sense to us.
None whatsoever. Reality is consistently proving to be far wilder than our most radical theories.
And that is exactly why science is never truly settled.
Never.
Every time we build a better eye to look at the sky stares back and gives us a completely new mystery.
Always.
So, what does this all mean?
I think it leaves us with a profound shift in perspective.
Okay.
If we go back to that idea of primordial black hole,
The secret seeds.
right, those secret seeds crushed into existence by the Big Bang, we really have to ask ourselves a fundamental question about the nature of our reality.
What's the question?
Well, we spent a century viewing a supermassive black hole as the ultimate destructive force, the great devourer at the end of time.
Right, the ultimate cosmic monster.
But if this JWST discovery holds true, if they were there at the very beginning, acting as the massive gravitational anchors that pulled the primordial gas together against the expansion of the universe,
Oh, wow.
then we have to ask, is a supermassive black hole a destructive force? Or was it actually the necessary violent architect that allowed our own Milky Way galaxy, our solar system, and eventually us to exist in the first place?
That is a staggering thought to end on. From an impossible monster in the cosmic maternity ward to the violent architect of our very existence. Thank you for joining us on this mind-bending exploration of the cosmos today. Keep your eyes on the stars, keep challenging what you think you know, and never stop questioning reality.